AS Physics. Look for A levels physics. It is divided into two parts. One is AS and the other one is A2. AS is having 3 units, Unit 1, Unit 2, and Unit 3. Where for A2, you have Unit 4, Unit 5, and Unit 6. So for AS, Unit 1, the code for this Unit 1 WPH11, and when you're doing AS physics, the code is XPH11. So for Unit 1, the code is WPH11, and what it includes, the topics which are there in this Unit 1. It includes the motion and graphs, it includes momentum. Momentum is actually there is a part of motion and graph, but separately I'm mentioning momentum, moment, the turning effect, include work energy power, and fluids, and the last part is materials. These are the topics which you will find in Unit 1. The topics which will cover Unit 2, the code is WPH12, and the topics which will cover this: waves, DC electricity, light. So these are the topics which will cover Unit 2. And for Unit 3, which is WPH13, it is alternate to practical. So the same way, you already have an idea how ATP paper, exam paper is there. So some experiment planning is there. You have to complete sometime the circuits, mentioning the reading in the table. That is alternate to practical, ATP. So let's start the first unit, Unit 1. The first one, the basic quantities. So basic or the fundamental quantities, there are 7 fundamental or basic quantities, which are length, mass, time, temperature or absolute thermodynamic temperature, current, electrical current, light intensity, or an amount of substance. So these are the fundamental quantities, and the units of these quantities are known as fundamental unit or basic unit or base units. So for length, it is meter. For mass, it is kilogram. For time, it is second. For temperature, it is Kelvin. Amount of substance is ampere. By mistake, current is ampere. Amount of substance is mole. And light intensity is candela. I was reading the amount of substance, that's why I just said amount of substance is current, but SI unit of length is meter, mass is kilogram, time is second, temperature is Kelvin, current is ampere, amount of substance is mole, and light intensity is candela. Instead of writing this full, for meter we use small m, for kilogram we use kg, for second we use small s, for Kelvin we'll use capital K, for ampere we use capital A, for amount of substance MOL, and light intensity candela CD. A quantity other than this is known as a derived quantity, or the units are known as a derived unit. So quantities other than these 7 are known as derived quantities, and their units are known as derived units. So example, if I write pressure, that's a derived quantity. If I write force, that's a derived quantity. If I write density, that's a derived quantity. If I write area, that is also a derived because it's a product of length into width. It's not a basic. And their units are known as derived unit. Like example, pressure is Pascal. So Pascal is a derived unit. Force is Newton. It's a derived unit. Density is kilogram per meter cube. It's a derived unit. Area is meter square. So it is a derived unit. Is it clear till now? Is it clear?
Yes.
So a simple question, normally they ask express the following quantities as base units. So you want to express the following quantities as base units. And what are the base units? As we know, the base units, it's mass, kilogram, second, Kelvin, ampere, mole, and candela. These are the base unit. So how we can express, like example, the first one, if I say express force into base units, like what is represent its unit is Newton, but in terms of base unit means using a fundamental or the basic units. So first, to do this, you should write a formula. So what is the formula for force? F is equals to ma. Very commonly you use this formula. Force is equals to mass multiplied by acceleration. So what is mass? Mass is kg. And what is acceleration? Acceleration is meter per second square. The unit of acceleration is meter per second square. So when I solve this, it will be kilogram meter divided by second square. Or when we represent in terms of base unit, normally we use all in numerator. So if second square move to numerator, it will be kilogram meter second raised to power minus 2. That's a base unit. So basically, when we say Newton, actually Newton in terms of base unit is equals to kilogram meter second raised to power minus 2. Same way, if we have pressure, so pressure is what? Pressure is force acting on unit area. So the formula to calculate a pressure, P is equals to F divided by A. F is a force, the unit is Newton, A is area meter square. But what is Newton? Newton itself is kilogram meter per second square. So in place of Newton, because we want to represent all of them in base unit, so Newton is kilogram meter second minus 2. And this meter square is there. So this m will cancel with this square. So it will be kilogram second minus 2 divided by meter. But I told you all we represent in numerator. So if I meter raised to power 1, I move to up like in a numerator. So it will become kilogram meter minus 1 second minus 2. Is it clear? Representing this as a base unit. Same way, if I say work done, so represent work done, actually it is joules, as the unit drive unit is joule. But what are the other units? So work done, what is work done? We know work done is equals to force multiplied by distance. The unit of the force is Newton and unit of distance is meter. What is Newton? Newton is kilogram meter second raised to power minus 2, and this is multiplied by meter. So when we multiply, what it will become? It will become kilogram meter square second minus 2. So what it shows? It shows that this kilogram meter square second minus 2 is equivalent to joules. Is it clear? We drive these quantities as the base units. So if a question is the base unit for force, so base unit of force is not Newton. The base unit for force is kilogram meter second minus 2. If it is a drive unit, then it's Newton. Same thing. So this Pascal, this kilogram, meter minus 1, second minus 2 is equivalent to Pascal. So if we say express pressure in terms of base unit, so it is kilogram, meter minus 1, second minus 2. And work done, it is kilogram, meter square, second minus 2. Then a quantity, a physical quantity, a measurable quantity can be a scalar or it can be a vector. A scalar quantity is having magnitude, unit, and direction. No direction. Where vector quantity is having a magnitude, unit, and direction. So if it is having magnitude, unit, and direction, all three things are there, we call that as a vector quantity. If there's magnitude and unit but no direction, we call it scalar. What's the meaning of a magnitude? Magnitude means number, value. Like if I say today's temperature is 30 degrees centigrade. So what this 30 is representing, this represents the magnitude. What this degree centigrade or Celsius representing is represent unit. But there is no direction is involved. So we call this quantity as a scalar quantity, which is not represented by direction. But if a quantity is represented by a direction, like if I say 30 Newton towards east, west, north, south. So 30, what 30 is representing? It is representing magnitude. What Newton is representing? A unit. And what east is representing? A direction. So it has magnitude, unit, as well as direction. What we call this quantity? We call this quantity as a vector quantity. So vector quantities have all these three things: magnitude, unit, and direction. Some examples of scalar quantities, like time is a scalar, temperature is a scalar, and length is also a scalar. But about the vector quantity, force or weight, velocity, and acceleration. These all are vector quantities. They have magnitude, unit, and direction. Is it clear? So for a vector quantity, we can use a rule. We call that as a vector addition rule. Or we can also find a resultant of the vector by using this vector addition rule. So what we can do, for example, it depends on if two vectors are acting in same direction. So what we will do to get the result, we will simply add them. So an object experiencing a force of 30 Newton and 70 Newton, and I want a result of these two vectors because they are acting in the same direction. So to get the result, it will be 30 plus 70, which is equals to 100 Newton, and that is towards right hand side. It's 100 Newton towards right. That's a resultant of these two vectors. If they're acting in opposite direction, so to get the result, if they're acting in opposite direction, how I'll get or find the result, I will subtract them. So example, two vectors are there. A 70 is towards right and 30 is towards left. And I need a resultant. So how I'll get the resultant of these two as they're acting in opposite direction? So I will get resultant by subtraction. So in this case, it will be greater vector minus smaller vector. I'll get the resultant, which is 40 Newton, and the direction of this resultant is towards right hand side. But if two vectors are making certain angle, the vectors are making angle with each other and we want to find the resultant. So to get the resultant, what we will do, then we have options. We can use, and if this is only for two vectors, like because we are finding a resultant of two vectors here. So if two vectors making angle with each other, to get the result, we can use a parallelogram method. Both are in the scale diagram, or we can consider it as a triangle method. How we will do a parallelogram or a triangle method to get the resultant of these two vectors? So basically, both methods are same, but in one case we consider them as a sides of a parallelogram, and another one we consider them as a sides of a triangle. So if we are finding using a parallelogram method, the rule is draw both vectors from same point and diagonal represent resultant of vector. So example, say we have an object which is experiencing force so we have an object which is experiencing force, say 60 Newton and 20 Newton or 40 Newtons. With the angle between them is 30 degrees. And both these methods, the first step is we'll select a proper scale. Because Newton, we don't have a scale in Newton here, so we don't know like 60 Newton stands for what length. So we should always select a proper scale. So example, first I select that 10 Newton is equals to 1 centimeter. So if 10 Newton is equals to 1 centimeter, so 40 Newton is equals to 4 centimeter, and 60 Newtons is equals to 6 centimeter. This is what we select as our scale. You can select any number, it's up to you. Now what we do, we should draw both vectors from the same point. So I mark a point and I'll draw both vector from same point, like 60 Newton and 40 Newton I should draw. So I will draw 6 centimeter and I will draw 4 centimeter from the same point. They should have a same starting point. Then I will complete a parallelogram. How I complete a parallelogram? I will open the compass. I can draw an arc. Open the compass 6 centimeter and draw an arc. So when I draw an arc, the diagonal of this parallelogram, what it represent the resultant. And then I can complete this figure as a parallelogram. So you can see this method, why it is called a parallelogram, because when you complete the figure, it will make a parallelogram. You will measure the length of this resultant according to the ruler, like using a ruler, you'll measure length. Example, if it was coming out, say 8 centimeter, then you will get this 8 centimeter. And direction, the term direction means the angle. So you can measure the angle from 60 Newton or you can measure the angle from 40 Newton, which is 4 centimeter. So magnitude is a value and the direction is the angle which it is making with one of the vector. Is it clear, the parallelogram method? The parallelogram method to find the resultant. Same way, you can also use a yes, for the direction, you will measure the angle with one of the vectors and that is referred as direction. Same way, you can use a triangle method. What is a triangle method? In a triangle method, you will also select the proper scale, select a suitable scale. But this time, the two vectors should be a side of a triangle. So what you will do, you will draw the first vector, then draw the second vector, from head of first vector, and to get the resultant, what is the resultant? The resultant is from tail of the first to the head of the last vector. So if resultant is from tail of the first to the head of the last, that's resultant. This is a triangle method. I'm using a same example so you can understand how it can be done. Say two vectors are there. One is 60 Newton, another one is 40 Newton, making angle 30 degrees with each other. a force of 60 Newton and a force of 40 Newton. First, we select a suitable scale as we did earlier here, you can see. So because I'm taking the same value, so I will select the same scale. Then you will draw the first vector. So I will draw the first vector. Like example, I drew 60 Newton. Okay, like this is the first vector. Which is 60 Newton equals to 6 centimeter. Then from the first vector, from the head of the first vector, I will draw the second vector. So I should draw in the same manner like I drew. This is 6 Newton, which is 60 Newton equal to 6 centimeter. Then from the first vector, I will draw the second vector. The angle between them is 30, not this angle. This angle will not be 30 because if I extend this angle will be 30, as you can see. So I drew 40 Newton now, which is 4 centimeter. Now what is the resultant? Resultant is from tail of the first, this is the first vector tail, and the head of the last. So when you join the tail of the first to the head of the last, this is called resultant of the vector. And you will get the same answer like if previously we were getting 8 centimeters, here also we will get 8 centimeter as a resultant, which is equivalent to 80 Newton. Is it clear? The triangle method. So in a triangle method, we draw the first vector, then from the head of the first vector, we draw the second vector, and joining from tail of the first to the head of the last. This is the tail of the first, and this one is the head of the last. So when we join them, we call that as a resultant vector. Is it clear? The triangle method. Then resolving the vector. Into rectangular component. What's the meaning? Resolving a vector into rectangular component means breaking the vector into component. Like you have a force which is 30 Newton. The idea of a rectangular component, first you should have an idea of a rectangular component. Look, what happened if I draw arrow up, it means it is a vertical component. If I draw an arrow down towards right or towards left, it is horizontal. Right or left is horizontal, up or down is vertical. So when we divide the force into its component, like what part is acting on x-axis horizontally and what part is acting on y-axis vertically, we call that as rectangular component. So example, if there is a force, you attach a rope to an object and you are applying a force, and your force is making 30 degrees here. So it is making angle 30 degrees with horizontal, and a force of 100 Newton is there. So actually this force is not horizontal, this is not vertical. It has both component. It has some horizontal and it has some vertical. So how to find a horizontal component and how to find a vertical component? So we use a triangle, right angle triangle. So if I complete this, triangle, this is a right angle triangle. So this part is known as the horizontal part and the other part is a vertical. So how I can find the horizontal part? As you can see, it's a right angle triangle. So this one is a base, perpendicular, hypotenuse. So I have the formula that sine theta is perpendicular over hypotenuse. So sine theta is there. Perpendicular, I don't know. The vertical component is a perpendicular. And what is hypotenuse? Hypotenuse is equals to 100. So it will be multiplied, or instead of taking 100, example, I'm taking a number here. Sorry, variable here, say f. So this will be, the hypotenuse will be equal to f. So f is divided, other side it will be multiplied. So what it shows the vertical component is equals to f sine theta. And what about horizontal component? Like we have cos theta is equals to base over hypotenuse. So cos theta, base we don't know. And what about hypotenuse? Hypotenuse is f. F is multiplied there. So we can say the base, this part, the base is equals to f cos theta. So whenever we are finding the horizontal component and we know the angle with x-axis, if we need a horizontal component, that's equal to f cos theta. And if we know we want to find the vertical component, we will use f sine theta. So if I say a force of 30 Newton making angle 45 with x-axis, what is a horizontal component and what is a vertical? So how to find a horizontal component? That's equal to f cos theta. You can see horizontal is equal to f. So means force is 30 cos 45. And the vertical component is equals to f sine theta. So f is 30 sine and 45. Is it clear? This is called a resolution, resolving a vector into its rectangular component, like breaking the vector into horizontal and vertical components. Is it clear?